Right, so in the previous session we have gone through fixed point method and Newton-Raphson method, and out of these two, Newton-Raphson method is a bit faster. The reason is we have considered up to first order differential, error is of the second order differential, whereas for fixed point method the error is at the order of first order differential. So one is linear in convergence, another is quadratic in convergence. So another method is bisection method. So here, so this is a kind of brute force. No, not even that. So we have to, in this method, we have to identify the interval where the exact solution lies. So we are given a function f of x is equal to 0, and we need to identify the value of x where the function becomes 0. So let's say if you draw a graph for that function f of x, let's say the function is like this, graph for f of x is like this. So here it is crossing, our aim is to identify the value of x where f of x becomes 0. So we are drawing a graph for f of x and identifying the location of x where f of x becomes 0. Okay, so here on one side f of x is positive, on the other side f of x is negative. And coming to here, on one side of the solution f of x is negative, on the other side f of x is positive. So most often when you have positive value of f of x and negative value of f of x, there exists at least one solution in between. So identify interval where f of x changes its sign. F of x value changes its sign. You need to identify that interval and divide it into half. Bisect the interval. So let's say this is the interval you have identified, and once you bisect it, you will reach this point, midpoint of these two. Okay. So then identify the interval on which side, you need to exclude one of the solutions. Let's say this is 1 and 2, these are the 2 points. So in between these two the solution exists. So now you identified the midpoint as the third point. Now you need to exclude one of these two solutions, either point 1 or point 2 need to be excluded, right? So in that case you have to check the sign again. If the third point, so sign of f of x1 is positive, let's say, f of x2 is negative, and if f of x3, so here I am calculating x3 is equal to x1 plus x2 by 2, midpoint of those two. If f of x3 is positive, if f of x3 is positive, exclude x1, replace x1. Okay, so I am replacing x1. Then the next midpoint, maybe this is x4, midpoint of 2 and 3. So then I need to check for the sign of x4, f of x4. If f of x4 is negative, so continue the process till you reach a solution. Okay. So now I am considering the same equation, x square minus 7x plus 10 is equal to 0. So the exact solutions are 2 and 5. These are known things. So for the timing, I am considering what? I am considering an interval. I need to identify an interval where the function changes its sign. So I am considering 2 points, 1 and 3. I am considering this as x1, this as x2. Now, what is f of x1? 1 square minus 7 into 1 plus 10. 1 minus 7 plus 10. 11 minus 7, 4. F of x2, 2 square minus 7 into 2 plus 10. Three, na? Okay. In this case, it is 0. You substitute to it is 0. Right, if you substitute the other one, it is 3 square minus 7 into 3 plus 10. 9 minus 21 plus 10. Minus 2. Minus 2. So on one side you got a positive number, on the other side you got a negative number. Then you divide the interval. 1 plus. Oh, yes, this is direct. So I have to go for a different one. So take it as 4 then. So it is 4 square minus 7 into 4 plus 10. 16 minus 28 plus 10. Minus 2 again. Okay, so now if you take the midpoint of those two, then calculate f of 2.5. 2.5 square minus 7 into 2.5 plus 10. So this is 6.25 minus 17.5 plus 10. 16.25. So it is 1.25 minus 1.25. So which one should we replace? So I need to replace x2. So new x2 is 2.5. Then again we need to calculate the midpoint of those two. So 1 plus 2.5 by 2. 3.5 by 2, 1.77. So f of 1.75 might be a positive number. So you need to replace x1. So now the new interval is 1.75 plus 2.5 by 2. The process continues till you reach a required accuracy. So 1 decimal accuracy or 2 decimal accuracy, whatever level of accuracy you go, you need to continue till that level. Okay, the first aspect is you need to identify an interval where the function changes its sign. So that is the first step, and further the process continues. Then how to write a program for this? So I'm considering three variables x, x1, x2 and y. రెండు రియల్ నెంబర్స్ ఎంటర్ చేయమంటున్నాను. Then we need to check whether the function changes sign or not. Then ఎట్లా ఐడెంటిఫై చేయాలండి? So we need to give a condition. Do while what should be the condition? So we have different possibilities. Like f of x1 may be positive and f of x2 may be negative. So f of x1 less than 0 and f of x2 greater than 0, or f of x1 greater than 0 and f of x2 less than 0. So is there any other possibility? Is there any shortcut to verify both of them in one shot? That requires 4 times function calls. We need to call the function for 4 times. And we have 3 logical operations. Right? So the condition is f of x1 less than 0 and f of x2 greater than 0, or f of x1 greater than 0 and f of x2 less than 0. So how many operations are there? You have 4 function calls and 4 comparative statements and 3 logical operations. So there are 11 operations, 4 function calls, 4 comparative statements, and 3 logical operations. So you need to do 11 operations to confirm that. Any alternative? Is there any alternative? So if you multiply both of them, then check the sign. Okay. Here we have to, the issue is here we have to check the accuracy. On the first step we have to check the accuracy. So while f of x greater than this, you have to calculate the midpoint of these two. And you need to check the sign. No. So before that we have to verify, right? We have to verify whether this condition is satisfied or not. So అది valid interval అవునా కాదనేది మనం కన్ఫర్మ్ చేయాలి. సో ఏం చేయాలండి? Alternative is multiply both of them. If the product is less than 0, both will have opposite signs. So if the product is less than 0, you can continue. So instead of that, we have to use a go to statement. F of x1 star f of x2 less than 0, then you need to continue this. రెండు less than 0 అయినప్పుడు మాత్రము కంటిన్యూ చేయాలి, అదర్వైజ్ గట్ గో టు దట్. సో ఇక్కడ ఏం చేయాలంటే, ఇప్పుడు ఇది less than 0, so in this case also we don't know which one is positive and which one is negative. So still the case is problematic. So we'll see that. So we are not sure. Let's say if x1 f of x1 is positive. Let's say if f of x1 is positive, and f of x2 is negative, and f of x, let's say, is positive. Then we have to replace x1. Otherwise, we have to replace x2. Okay. So in the other case, if f of x1 is negative and x2 is positive, So we have to modify it. So how many conditions do we need to compare? We don't know the sign of f of x1. We don't know the sign of f of x2. We are directly verifying the product. If it is less than 0, we are continuing. So then, alternative is, still we can continue with that ambiguity without knowing the sign of f of x1. So, check this. X is x1 plus x2 by 2. We have to do a real number division. So then, if f of x star f of x1 is less than 0, so that means what? x1 and x have opposite signs. x1 and x have opposite signs. Then this is negative. Then we have to replace x2. Then x2 is so you can write if statement directly like this. I mean, whatever operation in a single line, otherwise you have to use then. Then x2 is equal to x. Else x1 is equal to x. So the process continues. Again for the new value of so we have to define x first of all. X is equal to x1 plus x2 by 2. Once you define it, then you calculate the sign of the function. The process continues. So if this condition fails, directly control goes to reading two new numbers again. So and finally program name ఏమిందో then function so one thing that we missed here is we have to consider the absolute value of f of x. This one should be in the next line. That's all. So if you check the rate of convergence, this takes a longer time. So This converges in the powers of n, powers of 2, 2 power n. Rate of convergence is 2 power n. Whereas earlier methods, Newton-Raphson method is the fastest out of all the three we have studied. Fixed point method is linear. Newton-Raphson method is quadratic in convergence. This is in power series in the powers of 2.